Well, all right, everybody, let's get started. I know most of you. I think I've had most of you for class before, maybe statics or CAD or geomatics at one point. So first off, welcome back, everybody. Welcome to Marshall. I hope you all had a relaxing and productive summer and whatnot. So I'm going to first off begin with announcements and whatnot. And so I do have my little QR code here on the slide for attendance. I am going to be doing that in here this semester. And I think I had a point in a later slide where I said, bring up the QR code, but I'm going to go ahead and do it now. I am curious, though, how many of you have me 5 days a week this semester? Oh, I'm so sorry. I believe that has got to be a valid case for a violation of your rights afforded to you by the 8th Amendment against cruel and unusual punishment to have to deal with me 5 days a week. I will try and make it as enjoyable as possible. Okay. All right, a couple housekeeping items, and then we're going to go through the class as a whole. Always like to sort of say a little bit about why you're even in this class beyond just degree work said you had to have it. So first off, office hours. So my office hours are going to be Monday, Wednesday. Day one, I've got a typo because that's supposed to be Tuesday, Thursday. All right. So Monday, Wednesday, Friday, 1 p.m. to 3 p.m., and then Tuesday, Thursday, 10 to noon. I'm curious, so I added everybody to a OneNote for the class yesterday. I'm not sure if you received a link to that, but if not, the link is available on Blackboard, and we'll pull that up here in a second. But everybody in the class should be added to the class notebook. So we're going to be doing a lot of problems in here. So if you want a very short thesis statement for what this class is like, this class is a lot like Statics 2. I've heard a lot of students call this class like Statics 2. And so you can imagine a lot of the type of work that we're going to do. And so there's going to be a lot of board work, and I'm going to do it in OneNote so that way everybody can access it outside of class. So if there, as we're going on throughout the semester, if you have any issues accessing OneNote, let me know. Okay? So what we're going to do today is we're going to go through the operation of the class, logistics, what we're here to do, how the course is graded and whatnot. So let's go ahead and just jump right into it. I cannot help on day one. Always got to pull up a picture of the family, namely that little girl right there. Again, she was supposed to stay a baby, and she just kept getting bigger. And I still don't know what I'm supposed to do about that, so if there's anybody in here that has any tricks for that, let me know. That's her at Camden Park this past like April or May. So yeah. Like I said, everybody, or most of you all know who I am, but in case you don't, I'm Dr. Michelson. I'm a faculty here in the Civil Engineering Department. I also serve as the college's Associate Dean, and so my office is right up there, like one floor up. So I'm in the Dean's office. Pretty easy to get a hold of me. I did get lucky with my email address, just Michelson at Marshall, pretty easy to remember. I was born and raised here in West Virginia, did my PhD at WVU, came here, and this is my 12th year at Marshall, so I've been here for a little while. We're starting to get into the area of the curriculum where this is sort of, these classes are sort of like my baby. I mean, like anybody can sort of teach like CAD or statics, but like I am a structural engineer, so this is structural analysis. This is my bread and butter. I love this stuff. And so, like I said, I am a structural engineer, but my area of passion and my particular area of expertise is in bridges, and namely how to design them efficiently and economically, how to construct them. I've done a lot of work developing modular systems for short span bridge applications, and a lot of them have been installed in the field. So this is something I almost just sort of have to restrain myself because I could get way off topic talking about this stuff because I love this stuff. But forgive me if throughout later parts of the semester I keep referring things back to bridges. There is a whole other world of structural engineering, and that's looking at buildings. And I'll try and, I'll obviously, attack both, but again, bridges is my passion, so I'll refer to that a lot. Okay, so let's get into the nuts and bolts of how the class is going to be structure, no pun intended. Let's talk about the grading, which I think is probably like, we'll start there as a basis and expand from there. So I am going to take attendance in the class. The biggest grade component in this class is the homework. How many of you had me for statics? I'm curious. So if you had me for statics, I'm going to do the same thing in statics that I did in statics. I'm going to do that in here. Sort of the daily homework assignments, we're going to do those in here. For those of you that had me for 321, we probably will not do that in there, just because of the nature of the class and how that class is structured. But for those of you that did not have me for statics, I'll explain what that means here in a little bit. So the homework is the biggest part of the grade, the biggest singular component of the grade. We are going to have a class project in here. So the class project is going to be detailing a pedestrian truss that connects this building to that building, to the biotech building. So when they built this structure, they built it so that the elevation of the third floor of this engineering building matches with the elevation, the associated elevation on the biotech building. So if we wanted to build a bridge between the two buildings, we could. Sort of like how there's a bridge across 3rd Avenue. So we're going to do a bridge across these two buildings, and that's going to be our project and whatnot. So there'll be 2 deliverables for that throughout the semester. So the first deliverable will sort of be the conceptual phase, and then the second deliverable will be the real deal work that we do, that'll be due right before Thanksgiving break. This is the textbook. It's the Casamale 6th edition book. I do think that you should have a reference copy of structural analysis. I don't care if you get an electronic version or hard copy. I don't really care. But a lot of the homework is going to come out of this book. So what I typically do is I make that easier for you. Like I'll provide some info for you for the first week or so, if you're still waiting for the book to come in the mail. But after about week 2, if I assign problem 5.46, I'm going to assume you can look up problem 5.46. So after about week 2, I'll say you're sort of on your own. But that should give you enough time to access the textbook. Okay, so let's talk about operating the class. And then after I go through these few slides, I'm going to pull up Blackboard. I'll pull up the course syllabus to make sure I'm not missing anything and whatnot. So let's talk about technology and whatnot that you're going to need for the class. So first off, Blackboard. I am a religious user of Blackboard. I'm going to use it very regularly in this class. I've said numerous times on day 1 of the classes that I teach is that when I developed my teaching philosophy, basically the way I did it is I made a list of all the stuff that professors used to do that annoyed me when I was in college. I said I wasn't going to do that. Okay? And one of the things that always annoyed me is when I was taking a class and I didn't know what my grade was. I was like, why? I should know. And so I'll say with the volume of work coupled with using Blackboard, if you ever want to know what your grade is, it's going to be there live. And so I keep that updated pretty regularly. I'm also going to use Blackboard to distribute pretty much everything in the class. Things like the lecture notes, the homework assignments, all that stuff is going to be on Blackboard. So it'll all be there. We are going to be submitting homework via Blackboard. Now, I see a number of people in here with iPads, so I don't care if you do the homework on the iPad and then convert it to or export it to a PDF and upload that. That's fine. I've got no issue with that. If you want to do the homework on engineering paper and then snap it using Cam Scanner or Microsoft Lens or something like that, that's fine too. Just as long as you're able to submit it via Blackboard. You can also, if you get in a pinch, the department offices have scanners that you could use there as well. Okay, laptops. Okay, so a little bit later in the semester, both for the class project as well as for a topic that we're going to do a little bit later, you will need to install this software package called Mastan. Okay, a couple things about that. Number 1, it is totally free, so you don't have to pay for it. 2, it is both PC and Mac friendly, so it doesn't matter which operating system or which laptop that you use. Okay, I will bring up something Voldemort-esque. Mastan is based off of MATLAB, so if you have MATLAB still installed on your computer, you can do that. But I want to be absolutely crystal clear: Mastan is not MATLAB. You're not going to be writing code. You're not going to be writing programs with Mastan. That's not the way it works. It just uses the engine in the background. So there's 2 ways of installing Mascan. You can just install the standalone version, or it can be like an add-on to MATLAB. Either way, it works. Okay, and again, you're not going to be writing for loops. You're not going to be writing code. I promise. Okay. All right. Sound good? Okay. All right. Teams. I may use Teams a little bit here and there if we want to use it as like a backup. It probably doesn't matter that much for fall classes. Sometimes, like in spring classes, if we have like some really serious weather, we might use it to back up a lecture. But I don't really see myself using Teams a ton. But OneNote, like I said, I will use that pretty regularly to do the problems on the board. So I'll be doing the problems there on the screen, so you'll see me writing there in real time, and then you can access the stuff on the whiteboard, I should say, via OneNote. It's the same thing I did in statics. So the same thing I did in there is what I'm doing in here. Okay, and I say break out your smartphones for attendance. Did everybody get the QR code? Did anybody miss it? Okay. All right, so let's talk about the different components of the class. So again, attendance. I'm going to log the attendance at the beginning of class. And the way I do that is if you're there to snap the code at the beginning, it's full credit. If you got to pull the QR code up later because you were 10, 15 minutes late, I'm going to count you late. And if you weren't there, that's absent. And so I'll log that on Blackboard. I'm usually pretty easy to get along with in terms of like if you had a job interview or you were sick or whatnot. Like I'm pretty easy to get along with. I will say that if you miss an exam, I have got to have a university excuse absences for an exam. But if you miss a day here and there I get it, stuff happens. Just let me know, okay? You are still responsible for anything that we talk about during class, but that goes into the next point here. So I am recording everything that's on the screen as well as the audio right here. I'm recording all of that. So anything that we do on the board is going to be recorded, and I'm going to post that to a YouTube playlist. And the link to that YouTube playlist is going to be inside Blackboard. So you'll get like everything. You'll see everything that's on the screen and hear everything. That'll all be on that recording. Now, it might not be immediately posted. So, for example, this class meets from 11 a.m. to 11:50. I will probably not every day upload the video at 11:51. Okay, you got to like give me a little bit. Especially, I'll just level with you on week one as the associate dean. Ooh, it's rapid fire, just dealing with stuff in the background. So it might be a little bit before I upload it, but I will try and upload that pretty regularly, or with regular frequency. Okay, homework. So the way that homework's going to work in here, again, we're going to have a very frequent homework schedule. So, for example, I'll assign homework on Monday that's due Wednesday, on Wednesday that's due Friday, on Friday that's due Monday. Okay, and for the most part, we'll be doing that through the whole semester. Now, the good part is that each assignment is not very big, okay? So instead of giving you like 10 homeworks where each homework has 4 problems, the idea is I'll just give you 40 homeworks and each has 1 problem. So the net amount of work throughout the semester is really not any more than if we were to collect it all together. I started doing that as a result of the pandemic because I wanted to give students a reason to sort of like log in and focus and whatnot, but I kind of thought I was going to get raked over the coals when I did that, in my course evals, that all my students were going to say, why did you do that? That was horrible. But actually most students tend to like it. They tend to prefer, I think what I've heard is, it's nice that you do it, Dr. Mike, but if every single one of our professors did it, it would be horrible. So I was first. But I will say that, look, the way that you learn this stuff is to do the work. But again, I also understand that life happens. If you miss a homework assignment, it's not going to result in a letter grade drop. It's just not. That's another sort of benefit of it, is that because there's so many homework assignments, they're all not, like each individual assignment isn't super high stakes. Now, if you're not turning in, 15, 16 homework assignments, well, that's different, But if we have 35 homework assignments and you turn in 34 of them and you just miss one, it's okay. It's not the end of the world, okay? And typically the way that I format those assignments is they are directly related to what we talked about. So for example, if we're doing truss analyses, we'll have a lecture on the method of sections, and then we will have a homework assignment right after that on the method of sections due in the next couple days. So it also, it helps you with recollection because you're using that stuff like right after we talked about it in class. So it's not, oh, wait, Dr. Mike assigned that homework assignment 2 weeks ago. Wait, what were we talking about? You know, it forces you to use it on a regular basis. In terms of formatting, I do want it on like either quad paper or what I would say copier paper. And mainly that's because if you use your phone and scan it, I want the scan to come out legible. You do need to, like handwriting, I want your handwriting to be fairly neat. In this class, you're going to draw a lot of diagrams and a lot of figures. So having a straight edge is not the worst idea in the world. And then on the sheets, make sure you include, you know, your name, your course, homework number, the pagination, you know, page 1 out of 3, page 2 out of 3, and so on and so forth. And again, like I said, if you want to do it on a tablet and then upload, that's fine. That's really okay. So typically what I'll do for the homework assignments is they're due right before class. So I'm gonna give you a homework assignment on Wednesday. It's gonna be due Friday at 11 a.m. Okay. If it's late, it's late. Okay. But I will accept late homework until it's graded and the solution is returned. Once I grade it, post the grades and the solution's posted, it's over and that homework assignment's a 0. Okay. Does that make sense? All right. Any questions on that? Okay. All right, so like I said, there will be an analysis project that's focused on laying out a pedestrian truss that connects this building to that building. We're going to talk about that a little bit later in the semester. I do want to talk about exams. Again, we don't have exams in college. We have celebrations of learning. We're going to be celebrating 3 times in this class. There'll be 2 during the semester, and there'll be a 3rd one during finals week. Okay. Now, my exams are not intended in this course to be comprehensive, but I'm using that, I'm very choosy with my words here. I'm saying they're not intended to be comprehensive. In other words, there's going to be material that carries over from one exam to another, but there's nothing I can do about that because that's just the nature of structural analysis. So for example, both on exam 1 and exam 2, you're going to have to know how to compute support reactions. That's just because you need that skill in order to be able to either analyze trusses or draw shear and moment diagrams. So you're just like, it's going to be on both exams. Doesn't mean I'm explicitly examining you on that on both exams, but it's going to be there. So just be aware of that. But I will say that I don't really have a ton of complaints from students saying that my exams are too long. Like one of the things, like I said, that list of stuff that professors that used to do that bugged me. And one of the things that used to bug me is that when a professor gave me an exam that would take 4 hours to do and give me 50 minutes. That to me was not an exercise of my ability to negotiate the material. It was more a test to see how fast I could write and how fast I could hit buttons on the calculator, and it didn't really examine me effectively. So I tend to use a rule of 3. So in other words, if a problem takes me 10 minutes to do, I'm going to give you 30 minutes to do it. Okay, that's the rule I use when I'm building exams, and it tends to work pretty well. In fact, once I make an exam, I take the exam and I time myself, and if it takes too long, I'll pare it down. So that's not really I found to be a big issue. Okay, let's talk about AI. So I had to include, you know, Terminator, and bless you, Agent Smith from The Matrix. I couldn't help it. But so I want to give you my attitude about AI, but you'll see where I'm getting at here in a bit. I am not a professor that's going to deny reality that AI in fact exists and is out there, but not only is it there, my attitude is if it's useful, okay, like you know, as long as it's appropriately cited and appropriately referenced, I don't know that I have a big issue with that. Okay, so I'll give you an example. In the first submission of the analysis project, you are going to have to develop 3 representative truss layouts, and I might ask you, well, how did you do it? And if you said, yeah, I used ChatGPT to brainstorm, okay, that's fine. I really don't have an issue with that. But there are 2 problems with AI, and I'm going to try and make a point about this. There are 2 problems with AI that's going to be particularly challenging with this class. Okay, number 1, AI does tend to have a little bit of a problem with computational repeatability. Okay, and what I mean by that is open up ChatGPT, give it a list of 10 numbers, and ask it to compute the standard deviation. It'll probably show you how to do it correctly, but I would check the numbers, because they're probably going to be wrong, okay? All right? And the other thing that it has a challenge with is it has a challenge with graphical computation, okay? It has a real big challenge with taking images and extracting from those images meaningful computational information, okay? And so to make the point, I was messing around with this. I was actually messing around with this yesterday because I wanted to see what it would do. So I said, okay, let's just play around with this, okay? So I found this problem out of the textbook. This is problem 5.7, and I said, draw the moment diagram for this beam, okay? Now, if you had statics, you know that, you know what moment diagrams are, right? So I don't have to, go back and explain this. We are going to really do moment diagrams in here. And so when I say that this is a very representative problem of what you would do in C312, I'm not kidding. This is about as fundamental as you could get, okay? And the prompt, draw the moment diagram for this beam, that is very fundamental, okay? So I said, let's see what happens, okay? So I said, let's see what happens when we copy and paste this picture into the prompt and say, draw the moment diagram. And so ChatGPT gave me this, okay? Google Gemini gave me that. Microsoft Copilot gave me that, okay? Now, first off, they're not the same, okay? Now, here's the question. Which one of these is correct? Which one's correct?
I don't think any of them.
You're right. None of them are correct. None of them are right. They aren't. Now, here's the thing. So I started thinking about this, and I said, okay, I know what the correct answer looks like. Okay, and I'm going to be honest. I think with enough time and energy, I could sit there with these engines and go, wait a minute, that's not right. You need to fix this. Okay. Wait, this curve doesn't look right, you need to do this, okay? So a clear example is if you look at the Google Gemini one, it says, right here, it says support A and support B. Well, support B is over here, it's not over here. It saw this letter B and thought, well, that's where the roller is, but that's not where the roller is, the roller's over here. So I could say, wait a minute, Google Gemini, you got that wrong, and it'll redo it, okay? And I could go through and change some things. I could say, wait a minute, you have a linear load diagram, so anytime you have a uniformly distributed load, the moment diagram should be parabolic, not linear, right? And I could go through and start changing things. I bet with a little bit of time, I could get the right answer. But the point is, I know what the answer is. I already know. So what I'm doing is I'm going to these generative AI engines, and I'm having it do what it needs to do to get the answer that I already know. But if I'm assigning you a problem, you might not know what the answer is. Do you see what I mean? So I'm approaching it with the benefit of I know how to do this stuff. Now, so a lot of what I'm going to teach you, though, this semester is going to be things like pattern recognition. Like, if you have a uniformly distributed load, that means your moment diagram should be parabolic. If you have a concentrated moment like we do here at the end, that should be a sudden jump in the moment diagram. Again, I'm not stupid. I know that AI isn't going anywhere, but if you're going to use it, I want you to understand its limitations, where it works and where it doesn't, okay? So that's sort of the point I'm getting at. So, again, use it at your peril is all I say. There are things that it does very well, and there are things that it fails at. And I think in this class, it's not really going to help all that much, but this is just my way of explaining that. I started doing a truss analysis with it. Oh, God, it was horrible. It was nonsense, because I started going through the method of joints, and it was saying, oh, we're doing this based off an angle of 65 degrees. I'm like, it's not 65 degrees. And I spent so much time talking with it just to try and do one joint analysis. Like, this is nuts. It would drive you insane. So, okay. Yeah, that's just my experience. Okay. So far, so good? Okay. All right. So, just so you are aware, let's open up the course preview right now. So this is what the course should look like for you right now. So if you log into the course right now, you should see the course syllabus, which I'm going to pull up here in a second. You should see a link to the YouTube playlist. There's nothing in there right now because I'm recording this video right now. It'll get added here in a little bit. This is the link to the OneNote, the class notebook. I think everybody should try and access that at some point just to make sure that you can see it. If you can see a page in the content library called Classification of Structures, then you see it. But we'll mess around with that on Wednesday, so it's not a big deal. As for the lecture notes, I usually upload my lecture notes in chunks, okay? So I've got lecture notes up through not just the end of this week, but the end of next week. So I've got the next 2 weeks of lecture notes in there. And I don't have any homework assignments for today, so there's nothing in here beyond that you would need. And so, for example, if you go to topic 2, for example, topic 2, there's like 4 lectures in there. So lecture 3, lecture 4. And I usually have a separate handout for every lecture, a separate presentation for every day. So, sound good? Okay. All right, so let me pull up my syllabus. Okay, so here's the syllabus. I'm going to leaf through this really quickly to see if there's anything that I missed. There's my contact info, all camp carry stuff, generative AI, the textbook, course learning outcomes, pretty basic stuff, grade distribution. I do round final grades to the nearest percentage points. I'll go ahead and say that now. If you get an 89.7 in my class, you get an A, okay? If it's an 89.3, you get a B, okay? So I do round up, so let's see. Nothing here that I don't think I've already discussed. We will use Excel periodically in here, I'll say that. I'll let you know in advance when it's going to be an Excel day, but we will use Excel in here a little bit. But yeah, Excel and MathStand are going to be the only things that we use. All right, homework policy, attendance policy, I've already discussed that. Submission guidelines, I've already discussed that. If we have any written assignments in here, it'll either be like put it in Word and convert it to PDF, or there'll be something that you'll just type in Blackboard, just, one of those two. So it shouldn't be anything computationally challenging. So yeah, acceptable, unacceptable behavior, y'all know that. All right, sound good? Okay, let me pull up, I've got the course schedule here. I'm going to pull up an Excel version just because I think it's a little bit easier to negotiate. All right, so a couple key dates. So we're going to have no class on September the 1st because of Labor Day. Our first exam is going to be Monday, September 22nd. So if you had me for statics, you'll probably remember that we followed our class schedule pretty on point the whole semester. And this class is going to be the same way. So unless something goes awry, we're going to have our first exam on Monday, September 22nd. So go ahead and plan for that now. Regarding exams, so the way that I do exams, so on Friday, September 19th, we are going to have exam review day, okay? So the way that'll work is I will come in for about 10 minutes or so, and I'll talk about the format of the exam. I'll talk about the topics that the exam is going to cover, which, this exam is basically going to cover all this, right? And then I'm going to shut up, and you are going to ask me whatever you want, okay? If you want to go through a homework problem you didn't understand, we can talk about it. If you want to go through a topic that didn't make any sense, we can talk about it. You can ask me what is the answer to question 2 on the exam. I won't answer you, but you can ask whatever you want, okay? So I'm telling you that now because on exam review day, I want you to come prepared to grill me, make me earn my paycheck. So if there's something that on exam review day that you want to talk about, let's talk about it. And don't be shy when it comes to this stuff, because I guarantee you, if you have a burning question about something that you didn't understand on homework 2.3, chances are you're not the only one that has that question, and that's okay. Whether it's scholarships, loans, your parents, somebody put cash money on the table for you to be in this room, so take advantage of it. Okay, don't hesitate to ask questions. This is your time. So okay, all right. On Wednesday, September 17th, I'm going to go through the analysis project, and so I'm basically going to assign it that day. So you can see right here in purple where it says project assigned. There are 2 deliverables for the project. One of them is the Monday right after the October break, but when you see what I'm asking for in submittal 1, it is very light on the work requirement, so it's not like I'm saying, ooh, they have a long weekend, I'm going to make their weekend horrible by making them have a deliverable due on Monday. It's not that bad. It's really pretty straightforward. And part of the reason for this submission to have a submittal 1 and a submittal 2 is that you're going to be brainstorming different truss layouts, and if there's something wrong with the truss layout that you're going to end up using, this is a way of correcting it before you go really down the rabbit hole with changing things later. Yes?
Is it a group project?
No. Individual. Yes. No, this one, that's a great question. No, that's all individual, so. Great question. Okay, exam, so Friday, October 10th, that's our break, the little 2-day whatever they threw into October. So it actually did kind of work out very nice in this class because we're going to finish shear and moment diagrams right before the break. So the timing works out. It actually does work out very nicely in here. I'm not really a fan of let's start a new topic and then let's take a break. I don't like that. So it worked out very nicely in here, I will say. So our second exam is going to be Monday, October 27th. So it did sort of work out that Monday is that our exams are on Monday. So we can Friday study over the weekend, exam on Monday. So that did kind of work out pretty well. Wednesday, October 29th, and Halloween, those are our math stand days. Okay. So every now and then you'll see something like this. I don't know who that is, but I'm in class. I will call them back. I'll call them back. Okay. So if you look here for this homework assignment, it's assigned on Wednesday and it's due on Monday. Every now and then there'll be a homework assignment like that, but that's simply because that homework just bridges the gap for math stand, so it just takes a little longer. So, okay. All right. For the Friday before Thanksgiving break, so what I'll do is have sort of a live troubleshooting and Q&A with the project, because that's going to be the day that you have like a lot of stuff due on the project. And so if you're having problems with the truss layout or the member selection, that's a day where I'm just going to sort of camp out and be here in case you need me. But if you've got the project done, you don't need to be here. Just turn it in and get ready for turkey time. Okay? So we're going to have Thanksgiving break, and then we have our final topic, which goes through pre-finals week, review on December 8th, and our finals on Monday. So,
Is that the correct date for the final?
is
Because
it?
it conflicts with one of my other
Is it?
classes, and it says, I think ours is supposed to be on Tuesday then.
Ooh, you might be right. If that's so, that might be a typo on my part because last year this class was at 10. Let's see. Oh, wait, nope. You're right, it is at 11. Whoopsie. I'll get that corrected. Marshall University policy says I'm allowed 7 mistakes per semester. So I've already racked up 2, but I'm only going to count them as 0.1 on the mistake counter. I mean, it's a corrupt system because I'm the one that tracks the mistakes, so it never seems to hit 7. No, I'll fix that. I'll fix that. No, it's okay. Oh man, so people that have me 2 days, you have me back-to-back finals. Oh. That's your fault. You had to bring that up. Oh no. That really is a violation of Eighth Amendment rights right there, to have back-to-back finals with me. Oh God. It won't be that bad. It won't be that bad. Thank you, though, for bringing that up. Thank you. I appreciate that. Okay. So barring that, I'll get that edited. But are there any other questions about like how the course is operating, the grading scheme, AI, like anything? Everybody good? Okay. So I'm going to spend the next 15, 20 minutes talking about why you're taking this class, and then we'll call it for the day. So let's talk about why you're taking, go past this slide. Why are you taking CE 312? And I like talking about this on day one, because again, whether it's scholarships, loans, or your parents, somebody put cash money on the table for you to be in here, but at the end of the day, you're taking more, more than money is causing you to be in this room. You're spending your time in here. So why are you in this class? What benefit does it generate for you as students and up to be hopefully professional engineers? So yes, it is required for the degree, but why is it required for the degree? So maybe I should take a step back and say the name of this class is CE 312 Structural Analysis. What is structural analysis? What is that? Okay, and you could give find a textbook answer. You could find one on Wikipedia. You could chat GPT that one if you want. And what I could we could go on and on about it, but essentially what I would say is that structural analysis is the determination of the effects on physical structures and systems when they are subjected to some sort of external load. That is structural analysis in a nutshell, okay? And so I have two underlined words in this definition, effects and loads. So what do I mean by effects? So in other words, we have a system, we take that system, we apply some sort of force to it, some sort of load to it. What are we talking about with effects? So we're talking about things like support reactions. We're talking about things like the internal forces inside those members. So if we're talking about trusses, maybe axial forces, maybe we're talking about shears, moments. If we were talking about 3D systems, maybe there's elements that are twisting, so how much are they internally twisting and whatnot. And then there's also deformations. If I apply a load to this table, it deflects, it deforms. How much does it deform? Is it a half an inch? Is it 2.37 inches? What is it? Not only do structures translate, but they rotate as well. So translation would be the act of going from here to here or here to here. Rotation would be an angular change. Whenever we apply a load to a system, it goes through these effects. Okay? What about loads? What am I talking about with loads? What type of excitations do we place on structures? Well, I tend to break it down into, and most structural engineers tend to break it down into two categories. Gravity loads would be things that act in the direction of gravity. So, for example, the self-weight of the structure. So, if we were talking about this building, the building's own self-weight, transient loads like live loads, us, we are applying load to the floor system right now. Okay. There's also another gravity load that we have to consider. For example, when we're designing buildings, and that happens around here, around the time January, February, we're talking about snow. So snow loads on the roof or environmental impacts. So we have gravity loads, but we also have lateral loads. And the two most common lateral loads that we need to consider, loads that act this way, are wind, okay, and earthquakes. So now there's a whole lot more than this, but these are some very common loads that we apply to systems. So for example, if we were designing a retaining wall, we'd have the lateral earth pressure that the wall has to hold back. Hydro effects, if we were designing a dam, there's all the water that's got to hold back. So all that stuff. So these are the loads that we are applying to systems. These are the effects. Structural analysis is figuring this stuff out, essentially. Now, that's what it is. But I asked you, I said, why are you taking this class? So maybe the question is, who cares? Okay, so you have a truss, you apply some forces, and it deflects 1.37 inches. Who cares? Why would we care about that? The reason is that because we are civil engineers, and we need to understand those impacts to design. Okay? Our job as structural engineers is to design, evaluate, retrofit, rehabilitate civil engineering, infrastructure-related structures and systems. That's our job. Okay? Structural design is, I mean, if we wanted to define structural design, it is the art, and I do think it's a little bit of an art, of sizing and arranging systems and their components to safely support the loads that we're putting on them. Okay? And it doesn't matter if we're designing bridges or buildings, the idea is the same. With structural analysis, we can determine the axial force in this column or the bending moment in this beam. And it is those forces and those stresses and strains that we would ultimately say, here's how deep this beam needs to be. Here's how wide this column needs to be in order to safely resist those loads. That's what we're after. Okay? Does that make sense? Okay. Now, where do we start? Okay? Okay, you're like, I get it, okay? The goal is, here's a system, here's some loads. How do we handle that? Okay, so we need to adopt some basic tools in order to be able to do this, okay? And those tools primarily come from statics, and they come from mechanics of deformable bodies, Engineering 216, the class you probably have with Dr. Zatar, okay? So, for example, one tool that we're going to need is the concept of equilibrium, okay? So in other words, I place 50 pounds on top of this table. Let's say I place it right smack dab in the middle. This leg's going to hold 25 pounds. That leg's going to hold 25 pounds, right? 50 pounds down, 50 pounds up. The sum of the net forces in the system are 0. In order for structural systems to be in equilibrium, they are generally non-concurrent force systems, which means both the sum of the forces has to be equal to 0 and the sum of the moments has to be equal to 0, okay? We are going to be using those tools all semester, okay? Everybody in here has some familiarity with it. I mean, I taught you how to do it last year if you had me for statics. Whether you had me or not, everybody should be familiar with that, whether it's statics or physics or any of your other later courses that required it. Okay, what about constitutive relationships? Okay, now constitutive relationships are what you learned about in Engineering 216. We're going to explore this a lot more with the Tuesday-Thursday class that a lot of you are having me in CE 321. What is the relationship between stresses and strains in concrete, in steel, in timber, in aluminum, in whatever, right? Okay, so this is the way that we would define relationships on a normalized basis between applied loads and resulting deformation. So you probably remember the term Young's modulus or the elastic modulus, and that is a material-specific parameter, right? So the Young's modulus for structural steel is different than the Young's modulus for concrete because those materials are different, okay? That is another tool that we're going to need, okay? Another tool that we're going to need that's probably the most difficult one to, like, understand, like from a math perspective, but it's really easy to get from a visual perspective, is the idea of compatibility, okay? So when you apply deformations, let's say to a beam and whatnot, those displacements should be continuous, right? So remember in math you had continuous functions, and there are certain rules for how a continuous function behaves. Well, displacements for structural elements should be continuous as well. So in other words, this beam is sort of displacing in a smooth curve type fashion. It doesn't suddenly like jump down like that. If it did that, then the beam would be cracked and we'd have a bigger problem than our mathematical equations there. But the idea is that our those three tools are going to be how we link, for example, applied forces to resulting deformation. So we'll go from force to stress, stress to strain, strain to displacement. You know, kind of like what you did in Engineering 216. It's a lot of the same tools in here. Okay? Now, I want to close a little bit on this, this idea here, this idea of analytical modeling. So the name of this course is Structural Analysis. That implies that we are analyzing structures, but we're not. Okay? We do not analyze structures. We analyze mathematical models that represent structures, okay? That seems like, oh, Dr. Mike, it's Monday, you're splitting hairs, okay? We're just trying to figure out our class schedule, and what are you doing? It's the truth, okay? We do not analyze structures, we analyze mathematical models that represent them. So why do we do that? Well, by placing those inherent assumptions in our mathematical models, it makes the analysis not only easy to do, either by hand or by computer, but it makes it efficient, okay? The truth is, we can't get the 100% exact answer when we do a structural analysis problem. We can only get close enough. There are inherent assumptions in the work that we do. Like, I'll just give you an example. When we design, let's say, classrooms, okay, we assume usually around a 40 to 50% or 40 to 50 pounds per square foot load that accounts for the occupancy of the room, namely the desks, the people in this room. How accurate do you think that is? 40 to 50 pounds per square foot. Let me ask you this way. If we all leave and the 12 o'clock class comes in, is it going to be the exact same loads? It's going to be off, right? There's going to be some variability, okay? So structural analyses don't need to be 100% exact accurate. They just need to be close enough. Now, are the methods that I'm going to show you good enough to represent the systems that we analyze? Absolutely. I mean, we've been using these methods for this case, centuries, okay? But I need you to understand that there is a difference, okay? So, for example, let's take this bridge in Amsterdam right here. So you can see here there's this little, like, really, really short pier that's sticking out of the water right here, and you can see that the bridge sort of connects right here. So this is a support condition. Is that a roller? Is that a pin? Is that a fixed support? Okay? Which is appropriate? Well, it depends. It depends on the type of connection that's being placed here, and does that connection type align with the analysis methods that you use? See, the thing is, when you're analyzing a structure, like, you as the structural engineer are responsible for applying those assumptions correctly for the problem that you're looking at. Now, we're going to talk a little bit about that actually on Wednesday, like what is a fixed support, what is a roller support, what is a pin support. But the idea, I just want you to keep in the back of your head that you as the engineer are responsible for applying that model to the problem in question. And so there is a difference between, there may be a difference between what you're building in the field and what you're analyzing on paper. And so you just always need to keep that in the back of your mind. Ultimately, what we want to do is take three-dimensional complicated structures and turn them into this. This is a three-dimensional system, okay? But this is pretty common. We do this all the time, right? I want to take this and turn it into that. Now, y'all had me for statics. We did problems like this. I know that you could do this problem, okay? This is a little bit more challenging. So there is a little bit of accuracy loss when we go from here to here. But more often than not, with that accuracy loss, you also develop some conservatism. In other words, the actual forces in here would probably be a little bit less than what you get here. By simplifying the problem, you're adding some conservatism into your analysis. And that's going to be something that we talk about quite a bit throughout the semester. But it's just I know it's a very subtle point to make, especially on day one, but it is a very important one, that there is a difference between what you build and what you analyze. And so you just want to keep that in mind. Okay. Are there any questions overall about the class, about kind of what our focus is, what we're going to be doing here? Any questions? Well, for a lot of you, I will see you tomorrow. Again, my condolences. I'll pull up the code one more time in case anybody missed it, but I will see you all either Wednesday or tomorrow.